Hi students, all of you welcome. Welcome to Sunil Engineering Academy. I am Sunil Kumar Bandaru. Students, in this chemistry series, we have completed acids, bases and salts topic, metals topic also completed. Okay. So in the non-metals, we are going to discuss first one, carbon and its compounds. Okay. So in this class, we will discuss the very important points in the carbon and its compounds. Okay. And if you want previous, you can just click on the playlist and you can find out the previous sessions. So here carbon and its compounds. Okay, know very well about the carbon. Carbon is denoted with which letter? C. Carbon is denoted with letter C. Okay, and the C denoted as 6 12. What is this 6? Atomic number is 6. Mass number is 12. Okay, so coming to the electronic configuration of this carbon, 6 na 1s2, 2s2, 2p2. Okay, 2p2. So that means the configuration is like this. Okay, but according to Hund's rule, what is this Hund's rule? Half occupation. That is, electrons are trying to occupy half in all the orbitals. So for that, from that rule, we can say here 1s2. Here one electron is going to here, and here one electron is going to here. Okay, so that means here it is the 2s, it is the 2p. One electron is moving from this place to this, and one electron is moving to this. That means according to Hund's rule. So it always tries to half occupation at least. So one electron is moving from this one to this one electron is moving from this one to this one. So now in the second, okay, so in the second we have how many electrons are there? That is 4 electrons. 4 electrons. Okay, the second is the outermost orbit. So the electrons which are present in outermost orbit is called as valency electrons. Electrons present in outermost orbit. Electrons present in outermost orbit. That is second orbit. Outermost orbit is second orbit. So in the second orbit, how many electrons are there? Four electrons. So these are the valence electrons of the carbon. Okay. So carbon have how many valence electrons? 4 valency electrons. Okay. 4 valency electrons. And carbon exists in isotropic forms. Isotropic forms. That is C6. You know very well isotopes. Isotopes. Same atomic number, different mass number. 12, 13, 14, like that. Okay. So these are isotopes. Carbon isotopes. Okay. So in these carbon isotopes, C612, C613, C614, and also this carbon forms different structures, that is you can say allotropes of the carbons: graphite, diamond, C60. Okay, so coming to allotropes of carbon. Allotropes of the carbon. We have graphite, diamond. Let us take the first one as diamond. Diamond, graphite. Third one, C60. You can also call it as Buckminster fullerene. Buckminster fullerene. These are the allotropes of the carbon. Because carbon having a very good principle, that is catenation property. Due to the catenation property, it forms a big structures like diamond, graphite and C60. Carbon have very important property called catenation. Due to this, it forms into large molecules. Large molecule. Okay, so let us take the first two allotropes of this carbon is diamond. Okay, diamond. So this is the diamond structure. Diamond structure. Okay, so that means here these are the carbon atoms. Carbon atoms. Okay, and the bond between these carbon atoms is covalent bond. That is very strong bond. Very strong bond. Here, if you can consider, wait. If you can consider each carbon atom, each carbon atom combined with 1, 2, 3, 4. So each carbon atom will be combined with another 4 carbon atoms to form tetragonal shape. Okay, so here you can say each carbon atom combined with other 4 carbon atoms to form diamond. To form a diamond. So we know very well carbon having how many valence electrons? Just now I have given it has how many valence electrons? 4 valence electrons. These 4 valence electrons combined with another 4 carbon atoms. Combined with another 4 carbon atoms. If these 4 valence electrons are combined with another 4 carbon atoms means, then what are the free electrons? These 4 will be combined with another 4 carbon atoms. Okay, then free electrons are 0. So free electrons are 0. So in the diamond structure, the free electrons are 0. So finally you can say very important point. Free electrons in diamond is 0. So whenever the free electrons are 0, it may not allow the electricity. So it not allows electricity through it. Electricity through it. So it is a insulator. It is the perfect insulator. It acts as the insulator. Okay. So in the diamond, each carbon atom will be combined with another 4 carbon atoms. Okay, so each carbon atom will be another 4 atoms. For example, if it has 4 valence electrons, 1, 2, 3, 4. Okay, these will be combined with, one will be combined with this. Okay, one will be combined with this, one will be combined with this, one will be combined with this. That means now how many free electrons are available? None of the free electrons are available. So whenever there is no free electrons, no electricity. Okay, so we know very well current flows due to free electrons only. Whenever there are the free electrons, then only current will be flows. So otherwise no current is flowing. No current is flowing means you can say that is the insulator. That is the insulator. Okay. So note down the points belongs to this diamond. Diamond. Okay, in the diamond structure, each carbon atom combined with another 4 carbon atoms. Okay, we know carbon has 4 valency electrons. These are combined with another 4. So free electrons are 0. So it may not allow current through it. Current through it. So it acts as good insulator. Good insulator. Okay. Act as the good insulators. And here they are combined with which bond? Covalent bond. That is very strong bond. In this structure, very important, covalent bond are present throughout the lattice. Present throughout lattice. Okay. And we know very well it is very difficult to break this bond. Very difficult to break this bond. So it is very difficult to break this covalent bond. Okay, so that's why diamond is hardest material. Diamond is hardest one. Okay, diamond is hardest one, and it has some important properties. Those are, its density is very high. Density is 3.67, and its refractive index 2.41 or 2.44. Okay, and it is inert and poisonous. It is inert. Inert means it may not participate in the chemical reaction, and highly poisonous. Okay, and you know very well it is the insulator, bad conductor of electricity. Conductor of electricity. Okay, bad conductor of electricity. And you know very well where we are using this diamond. It is used in the ornaments and also drilling machines because of its hardness. Okay, and to cut the another diamonds. Okay, you know very well. For cutting the diamond, we use diamond only. Okay, and diamond is measured in carat. Is measured in carat. 1 carat is approximately 200 milligrams. 100 milligrams. Okay. Now coming to the next one, graphite. Graphite. This is the graphite structure. If you can consider graphite structure, here these are the carbon atoms. You can consider this carbon atom. Carbon atom having how many valence electrons? 4 valence electrons. So it is combined with 1 and here 2 and here 3. So it is combined with another 3 carbon atoms. So in diamond, each atom will be each atom combined with another 3 carbon atoms. 3 carbon atoms. You know very well carbon having 4 valence electrons, but if it combined with another 3 carbon atoms means 1 carbon atom is left. So that means it is act as free electron. Free electron. So graphite structure having how many free electrons? Are 1. So because of this free electron, it allows current through it. It allows the current through it. So it acts as the conductor. Act as the conductor. Very important. Why the graphite is act as a conductor and why diamond is not acting? Why? Because in the graphite structure we have the free electrons. Those free electrons allows the current through it. Okay, free electrons are allows the current through it. So here each, that is between the carbon atoms we have the covalent bonds. Okay, and also here a small electrical forces are also exist. Small electrical forces are also exist. Those bonds are nothing but van der Waal bonds. Van der Waal bonds. Okay, so we can break these van der Waal bonds. That is very difficult to break this carbon covalent bonds, but we can easily break this van der Waal. Okay, so let us take important points belongs to graphite. Graphite. Okay, graphite, each carbon atom combined with another 3 carbon atoms. Okay, we know carbon has 4 valence electrons. 4 valence electrons. In these 3 valence electrons combined with, in these 3 valency electrons combined with another 3 carbon atoms means one electron is left, that is the free electron. Okay, so we know that carbon has 4 valence electrons. In these 3 valence electrons are combined with another 3 carbon atoms. That means 1 electron is left, that is called as free electron. So number of free electrons in graphite is equal to 1. So because of this free electron, because of free electron, it allows current through it, current through it. So it act as conductor, it act as conductor, very important, act as conductor. Okay, now coming to the next point, that is properties of this graphite. Okay, and this graphite is very smooth and slippery nature, smooth and slippery nature. In olden days, that means in childhood days, we are playing with this graphite. Old radios, we have a white color or silvery color layered structures. Okay, so we are using that graphite is food for peacock tail. Okay, we are placing a peacock tail in our books now. Have you remembered or not? If you remember, give in the comment section. Okay, so while we are studying third class, fourth class, fifth class, in that time we are we kept one peacock tail in our books. Okay, for that the food of peacock tail is this graphite, white color layered structure. Okay, that is nothing but graphite. So here coming to the properties, the graphite is soft. Graphite is soft, smooth, layered structure. Layered structure. That means it is in the layered forms. This is one layer, this is another layer, this is another layer, this is another layer, like that. Okay, it is layered structure. Due to this, because of its soft, smooth layer structure, it is due to this used as lubricant in heavy machines. In heavy machine is used as a lubricant. Okay, and is used to make pencils. Okay, the lead of lead pencil, the lead pencil is made with graphite. Okay, very important question here. So what is the lead percentage in the lead pencil is 0. That means here lead, that is PV, lead percentage in lead pencil is 0. So there is no lead content. So the lead of lead pencil is made with graphite. Made with graphite. Okay. So it is also called as black lead. Okay, graphite. So it is called as black lead. Okay, black lead. And by heating this graphite with high pressure, we can convert it into a diamond. We can convert it into a diamond, but diamond may not become graphite. Okay. So here you can say on heating with high temperature and pressure, pressure, comma, in the presence of suitable catalyst, the presence of suitable catalyst, it may convert into diamond. Okay. And coming to important uses or applications of this graphite. It is a good conductor of electricity in non-metals. Of electricity in non-metals. Correct? Carbon is a non-metal. So in the non-metals, it is a very good conductor of electricity. Okay. And it is used as lubricant. I already said used as lubricant because of its soft and slippery nature in heavy machine. And also this graphite used as moderator in nuclear reactor. Very important question. Used as the moderator in nuclear reaction. Okay. And pencils are made with graphite. Pencils lead is made with graphite but not lead. Okay, so these are the very important uses of this graphite. After this graphite, we are going to discuss another allotrope of the carbon, that is Buckminster fullerene. Buckminster fullerene. You can say it is C60. C60. Okay, here what is happening? Each carbon atom will be combined with another 60 carbon atoms. Here, each carbon atom combined with another 60 carbon atoms and forms soccer ball shape. Soccer ball shape is football shape. Football shape. Okay, so make that point. Buckminster fullerene can also called as C60. C60. You can say it is pure form of carbon. Carbon. In this, each carbon atom combined with another 60 atoms. There are 60 carbon atoms. There are 60 carbon atoms. It is generally made with by heating graphite. Okay. It is made by heating graphite by using the electric arc. Right? In an electric arc. In the presence of gases, net gases. Net gases. as helium or argon or argon. Okay, and where we are using this C60, it is in the form of football shape. And where you are using this Buckminster fullerene, so it is used in microscopic ball bearings. It is ball nature, na football shape, rounded shape. So it can be reduce the friction. It is used for reduce the friction. Okay, so it is used as microscopic ball bearings, and also high weight batteries. Okay, because of its lightweight nature, wherever we use high weight batteries, also we are using this Buckminster fullerene. Okay, after this, in this carbon, we have very important thing is coal. Okay, so we need to discuss about the coal and different types of the coals. After that, we will discuss the oxides of this carbon monoxide, carbon dioxide, and those important uses. Okay, we will discuss those in the next session. We will discuss those in the next session. Here, coming to these, the very important points are carbon, and the number of valence electrons in the carbon are 4. Okay, and the allotropes of the carbon, diamond, graphite, and C16. Because of its which property, it will form large molecules because of catenation property. That is a very important question. So what are the bonds are present in the diamond? Covalent bonds. Okay, so each carbon atom will be combined with how many carbon atoms? 4 carbon atoms. So the number of free electrons are 0. And in the following, which is the act as the insulator, that is diamond, because it may not allow the electricity through it. Okay, and here I have given all the important points. And graphite and C16. Okay. And while discussing MCQs, you can get all the questions and you will get a very good practice. No need of worry. Okay. Okay, students, all of you, thank you so much for watching. Take care. Bye, guys.